Hello, we welcome you in the Gyan Sopan segment of our channel Click Videoz. Today's topic is, why is the sky blue? About this there are many misconceptions, but the sky is blue because of three simple factors. The first is the fact that the sunlight is made up of light of many different wavelengths. The second factor is scattering of the sunlight when it reaches to the atmosphere of the earth. And the third factor is the sensitivity of our eyes to various colors. To know about the concept, we first need to understand the nature of light and how it interacts with the gas molecules that make up our atmosphere. We all know that the sunlight, which appears white to the human eye, is a mixture of all the colors of the rainbow. Light is a wave of energy and different colors. And all colors have different wavelengths. At one end of the spectrum is red light, which has the longest wavelength. And at the other end of the spectrum, there are blue and violet lights, which have a much shorter wavelength. For many purposes, sunlight can be thought of as an electromagnetic wave that causes the charged particles inside air molecules to oscillate up and down as the sunlight passes through the atmosphere. When this happens, the oscillating charge produces electromagnetic radiations at the same frequency as the incoming sunlight, but spread over all the different directions. This redirect of incoming sunlight by air molecules is called scattering. So the sunlight gets deflected by the tiny molecules of gases, mostly nitrogen and oxygen in the air. These molecules are much smaller than the wavelength of visible light, and the amount of scattering depends on the wavelength. These tiny molecules of gases presented in the air scatter the shorter wavelength light much more efficiently than longer wavelength light. This effect is called Rayleigh Scattering, named after Lord Rayleigh, who first discovered it. The blue component of the spectrum of visible light has shorter wavelength and higher frequencies than the red component. Thus, as sunlight of all colors passes through air, the blue part causes charged particles to oscillate faster than does the red part. The faster the oscillation, the more scattered light is produced. So, blue is scattered more strongly than red. So, with all that said, you may have one more question. If the shorter wavelength light is scattered more efficiently, why doesn't the sky appear violet? Indeed, there actually is a greater amount of violet light coming from the atmosphere than blue light. But there is also a mix of the other colors as well. And because our eyes have three types of cones in them for detecting colors, along with the monochromatic rods, it is the signals from all four that need to be interpreted by our brain when it comes to assigning a color. Each type of cone and the rods are sensitive to light of different wavelengths, but all of them get stimulated to some degree by the sky. Our eyes respond more strongly to blue, cyan and green wavelengths of light than they do to violet. Even though there is more violet light, it is not enough to overcome the strong blue signal our brain delivers. So, blue light is scattered more than the other colors. This is why we see a blue sky most of the time. Hope you would like this video. Please like, share and subscribe this channel. We will meet you with a new interesting fact very soon. Bye-bye.